So hopefully you watched this video because this one explains obviously cos and then sine tangent functions as well, really in detail. So please make sure you watch that video and make some notes, but I'll explain briefly some of the key components of a tangent function. If you understand sine functions and cos functions really well, you should be able to understand tan functions easily as well because it incorporates these two. The reason behind it is because tan theta actually can be written in terms of sine and cos theta. So as we know, that's the ratio, sine theta over cos theta, and that's we write that as a tan theta. So let's have a look. In this case, we have seen that the p cos theta sine theta is a point which is free to move around the unit circle, and if OP, so this length over here, is extended to meet the tangent at A over here, the intersection between these lines occur at Q, 1, tan theta. This enables us to define the tangent function. Alright, so for theta in quadrant 2, sine theta is positive, right, using our all silly turtles crawl, and cos theta is negative, and so tan theta ends up being negative. As before, our OP is extended to meet the tangent at A at Q, 1, tan theta. For theta in quadrant 3, sine theta and cos theta are both negative. All silly turtles crawl. So quadrant 3, only tan is a positive, so tan becomes a positive. This clearly demonstrates that Q is back above the x-axis as well. So this tangent is the same. It's a positive tangent. This one is a negative tangent, which is a slope as well. Alright, so if I want to draw the regular tan theta, tan x graph, this is what it would look like. Some of the key components you really want to know is that zeros, also known as x-intercepts or roots, come from when sine theta, I'm just going to write theta, not x, equals 0. Now that's because in a fraction, so our tan theta equals sine theta over cos theta, if I want to find zeros where this is 0, I can't actually have my denominator be 0, so the only option is when my numerator is 0. So that's the idea behind it. So it's really important that you write this down somewhere. You might have already done it from the video. Now another thing is undefined. Unlike sine and cos theta graphs, tan theta has something called an asymptote, which are the dotted lines, basically where the function does not exist. Now this happens when, I might use different colors to write the rules. This happens when cos theta equals 0. Now that's because when we think of a fraction, so think about a fraction, when is it undefined? When does your calculator give you an error answer? Well, it is when the denominator is 0, so that's exactly why. So in order to find those points, rather than me just telling you where they are, let's actually have a look at sine theta functions and see if we can figure out the zeros of the tangent function. So I've copied and pasted it for you. So that one's sine theta, as you can see, and that one's the cos theta. So we're going to have a look at the zeros first. So let's have a look. So basically sine theta, when the zeros of it, is going to be the zeros for our tangent function. Okay, pretty straightforward. So I see a 0 here, so I'm going to write them down. Zeros are 0, another one here, etc. So every pi, 2 pi, 3 pi, etc. Okay, so that's going to be our zeros. So let's see if we can find that on our tangent functions. So I'm going to get a highlighter and show you. I've got a 0 at 0. I've got another 0 at pi. I've got another 0 at 2 pi. And if I go backwards, it'll be minus pi, minus 2 pi, etc. So hopefully you can see that it's going to be every pi. So I'm going to write 0 plus or minus pi k. What that means is starting from 0, I could go pi, positive, or negative, or 2 lots of positive, or 3 lots of positive, etc. Okay, so that's what it means. Let's have a look at the cos theta to figure out where it's undefined. So basically it's when cos theta equals 0. Okay, so my zeros of cos theta is going to be when my tangent function is undefined. So let me highlight them. That's a 0 and that's a 0, and I'll write them for you. So zeros of cos theta is going to be pi over 2, 3 pi over 2, and etc. It'll keep moving on. So let me go back and see if we can locate these points. Use a different color. So, what was it? Pi over 2 and 3 pi over 2. So, pi over 2, do you see those dotted lines? That demonstrates an asymptote. So, undefined at 3 pi over 2, and you can see that it keeps going on at that same interval. 5 pi over 2, and then if I go backwards from 0, it's negative pi over 2, negative 3 pi over 2, etc. So those are the main things you really need to know. Other than that, you just need to know that it goes, there's no amplitude, it just goes on forever, and it gets bigger and higher from bigger and smaller at the same increment. So that's what our tan theta looks like, and hopefully you should be able to draw this once you are able to draw it, sine theta and cos theta, without having to have a look at the answers. So tan theta has, again, a period of pi, range that has, range is the y-axis. It can be any number, but however there is a vertical asymptote, which is x equals pi over 2 plus k pi. So k can be any integer, so 1, 2, 3, negative 1, etc. It just means every pi from that pi over 2, you see a vertical asymptote. So hopefully we can summarize that and draw that in our books. Now, transformation for tangent functions, we can summarize in these dot points. Graph of y equals tan bx, so as you can see, the b is inside the function. B is greater than 0 is obtained by a horizontal dilation of y equals tan x with a scale factor of 1 over b. So that's a very important fact you should write down. The graph has a period pi over b. Okay, please write these down. Another point, a graph of y equals tan x take c. If it's a take c, it is a horizontal translation of c units. So just notice that minus c turns into a plus c. So translation with the horizontal, so if it's a minus, if it's a plus c units. If it's a plus, it'll be a minus c units, etc. Alright, so we're going to have a go at example 7. Without using technology, we have to give sketching the graph a go. So I'm going to start with a bit of a graphing paper, and then why don't I start by drawing my tan function. And I'm going to see if we can remember how to draw them without having a cheat sheet. So tan theta, right, we can write it as sine theta over cos theta. Now if you don't remember anything, that's okay, just start there. So what we know is two things. Okay, we have zeros of tan theta when, so one dot point, sine theta equals 0. Okay, we have asymptotes where cos theta equals 0. So have a think about your cos theta and your sine theta graphs, right? My sine theta looks something like this: pi over 2, pi, 3 pi over 2, 2 pi, and it goes something like this. So my zeros are pi and 2 pi. So I'm going to draw my zeros at pi and 2 pi in every intervals. Right, so this is my tan theta. So I'm going to maybe start to write pi. Sorry, I should say pi over 2. Pi. 3 pi over 2. 2 pi. I'm not sure if it's going to be enough scale. We might have to change it in a bit, but we'll just do that for now. So my tan theta graph would have a nice a 0 at pi and 2 pi. I know that. Alright, let's see if I can find the asymptote. So this was the sine theta. I'm going to see if I can just write the cos theta in this axis as well. Now cos theta starts from the downward curve first. So like this. Pi over 2, pi, 2 pi over 2, Oh, did I miss something? And then 2 pi. So it goes something like this. So it reaches from memory, goes something like this. There we go. Okay, so my zeros are pi over 2 and 3 pi over 2. So these are my asymptotes. Okay, maybe I'll highlight these zeros as well. So maybe I'll write a little blurb as well. Pi, 2 pi becomes roots on tan theta, pi over 2, 3 pi over 2 becomes asymptote on tan theta. Alright, so these are my asymptotes. And there we go. So if I want to draw a graph, my tan theta, it'll look something like this. Alright, I draw my arrowheads. Something like this. Okay, so that's my tan theta. But we don't want to draw tan theta or tan x. I could write tan x in this graph. I want to make sure I draw tan x plus pi over 4. Now, from our little green notes, we know that inside there's a minus c of horizontal translation. So our horizontal translation is, let me write some notes here. So because it's a plus, our horizontal translation is minus pi over 4, so left. Right, we're going left pi over 4. So basically every dot point just moves pi over 4 to the left. So I'm just going to use those dot points that we have. Actually, we do need to draw 0 to 3 pi, so I might have to extend a bit further. So I've only got 0 to 2 pi, so I'll extend further with my graph. So after 2 pi, it'll be, let me just use my calculator. So I'll write 2 pi plus pi over 2, which is 5 pi over 2. Oops, I might use green, some constant. And then I've got plus pi over 2, which is 3 pi, so I've just got to extend it to there. And then I've got my asymptote again over here. And then my pink dot for my 0. And there we go. Okay, so this is what I need for tan x, and then I'm just going to move every dot point minus pi over 4 to the left. So I might just write all of I'll calculate it and then draw it. So my first dot point, maybe I'll just do dot points like that. My pi over 2, which is an asymptote, maybe I'll just write all the asymptotes and then do your zeros together. So my new asymptote will be pi over 2, take pi over 4, and then I've got 3 pi over 2, take pi over 4, I've got 5 pi over 2, take pi over 4. So I just chuck that in the calculator so I can get the right accurate answers. So I get pi over 4, 5 pi over 4, and then 9 pi over 4. So those become my new asymptotes. Let me draw them in using a different color entirely so I'm not confused. Maybe I'll use black. So let me draw my new asymptotes. Pi over 4 will just be halfway between pi over 2 and 0, because it's half of that. 5 pi over 4 will be approximately between so that'll be 4 pi over 4, that'll be 6 pi over 4, so it'll just be right here. So each kind of box is pi over 4 in my scale. It might be a little bit different to your scale, so I know that it's moved that much to the left. So as you can see, they're all constant. And now let's figure out my new zeros. So my current zeros are 0, pi, 2 pi, and 3 pi. So I just got to take pi over 4 from all of them. That's negative pi over 4, which I won't have to draw because my scale is 0 to pi, 3 pi. Pi, take pi over 4 would be 3 pi over 4, 5 pi over 4, 11 pi over 4, I think. So let's move those over. I'll use black again for this one. So my new 0 is going to be negative pi over 4, so over here. My next 0 is going to be 3 pi over 4, which is over here. Next one is going to be 5 pi over 4, which was... Oh, that can't be right. Something's not right there. So I'll think. I can't have a 0 and an asymptote at the same place. Let's see where I went wrong. The calculation was wrong. It should be 8 pi over 4 take pi, so that would be 7 pi over 4. Alright, so 7 pi over 4 would be over here. And then over here. So I just got to draw them in. So it'll look something like this. And then this black line is going to be y equals 10x plus pi over 4. So hopefully you followed that. Please try it again by yourself as well and see if you understood it.